The next point is photosensitization. Photosensitization. So what is meant by photosensitization? An excited molecule, now see here, an excited molecule in the singlet or triplet state can transfer its energy to another molecule. So that transfer of energy from one molecule to another molecule in the excited state is known as an photosensitization. So this process is called photosensitization process. So now see here, in photosensitization what happens? The molecule is in the excited state, whether it is in singlet or triplet state, it can transfer its energy to another molecule. So that transfer of energy in the singlet or triplet state is known as an photosensitization. The excited molecule is called as donor. Now see here, the molecule which is in excited state, it has its energy, it donates its energy to another molecule, therefore it is called as an donor. And the other molecule which accept that energy, that molecule is known as an acceptor. So there are two types. One is donor, which transfer energy, and the second one is an acceptor, which take energy from that donor. So there is a symbol, D is nothing but donor, A is nothing but the acceptor. The donor molecule is called as an photosensitizer. Now see here, donor molecule gives energy, therefore it is known as an photosensitizer. So in the process, the donor molecule drops to S0 while the other molecule is excited, because now see here, if it is ground state S0, this is S1, and the electrons which are present initially in the lower energy state are now by absorption of light radiation are excited to the higher energy state, and this higher energy state molecule which is present in the singlet excited state, it transfers energy to another molecule. If it is suppose T1, it transfers molecule to another molecule and it drops through T, or it drops to ground state by giving energy. So this donor molecule which is present in the S1 state, by releasing energy to another molecule, drops to lower energy state. So this donor molecule drops to S0 while the other molecule which absorbs energy, it is get excited. It is important that the energy of excited state of the acceptor should be lower than that of the excited state of the donor. Now see here, what it means? It is important that the energy of the excited state of the acceptor should be एनर्जी त्याची काय असायला पाहिजे, कमी असली पाहिजे. कशापेक्षा? डोनरपेक्षा. का तर डोनरची एनर्जी ॲक्सेप्टरपेक्षा जर जास्त असेल तरच तो काय करू शकतो, एनर्जी रिलीज करू शकतो. ॲक्सेप्टरकडे जर एनर्जी कमी असेल तरच तो डोनरकडनं एनर्जी ॲब्सॉर्ब करू शकतो. म्हणून इथं काय सांगितलं आहे, इट इज इम्पॉर्टंट दॅट द एनर्जी ऑफ एक्साइटेड स्टेट ऑफ ॲक्सेप्टर शुड बी लोअर दॅन the excited state of the donor. So this is the second point. The first is when donor D gives energy, then it drops to S0 by releasing energy. Okay, in the second case, if donor want to give energy to the acceptor, the donor has more energy than the acceptor. Then and then only the energy is transferred from donor to the acceptor. Most of the photosensitization processes involve the triplet state of donor. Now see here, triplet state of donor and acceptor, and hence is termed as triplet energy transfer. So in this case of photosensitization, the donor and this acceptor are in the triplet state. They donate energy from, that is, this molecule donates energy to the acceptor, so that energy transfer takes place in the triplet state. Therefore that state is known as an triplet energy transfer. In this process, this process is very useful when a molecule cannot undergo direct excitation by irradiation. So why the photosensitization is important? If suppose one molecule is there, X molecule, if we give energy to the X, but this molecule does not undergoes excitation, so in that case we are giving energy through the mediator, that is a donor. So donor accept energy, it transfer energy to the molecule, and that molecule is get excited. So in that process only this photosensitization takes place, when molecule cannot undergo direct excitation by irradiation. So now see, the only simple mechanism is there. The phenomena of photosensitization cannot be described, can be described as follows by using this simple notation. So D is nothing but donor. Okay, D is donor. It initially absorb energy through a light, and it is get excited to the higher energy state, that is excited, that is singlet state. Okay, so initially is in the ground state, it absorb energy and it is goes to the singlet excited state, and in the singlet excited state it changes to triplet state. Now see here, 3 is nothing but the triplet. So initially this, suppose now this molecule is in the ground state. Okay, it absorb energy. By absorbing energy, the electrons of this molecule is get excited, that is molecules get excited to the higher energy state. Suppose it is S1 and we call as an D star. Okay, D1 star. So this is the gap of energy, that is it absorb energy in the ground state, that is S0 state, it goes to the higher energy state, and from that this is a triplet state. Okay, this is triplet state, and we know that the energy of triplet state is always lower than the energy of singlet. So this molecule crosses, that is intersystem crossing takes place, that is this molecule transfers energy, some energy, and it comes to the triplet state, that is D3 star. So that transfer of molecule from singlet to triplet, or change in spin of that molecule, is known as an intersystem crossing. Now see here, intersystem crossing, we have written on the arrow, that is ISC, intersystem crossing, that is only the intersystem, that is crossing takes place, but only the system, that is from singlet to triplet takes place. So that molecule which is in the triplet state, it gives energy to the acceptor, and after that acceptor, that is which is A1, is transferred to the triplet state. So this donor initially absorbs energy, there is an intersystem cross takes place, and from singlet to triplet transfer takes place, and that molecule which is present in the triplet now gives energy to acceptor, and this acceptor converts to a triplet state. So the transfer of energy is known as an photosensitization process. So D is a photosensitizer because it gives energy, therefore it is D is a donor and A is an acceptor. So this is nothing but a photosensitization process. The common examples which are taking place in the environment is nothing but the photosynthesis process, and the formation of vitamin D in the body, in the human or in the animal body, is only because of this photosensitization process. So the molecules which gives energy are known as the donor, okay, and we also call as a photosensitizer. So the common examples of photosensitizer in the organic compounds are benzophenone, acetophenone and naphthalene. So are these some examples of the photosensitizers which are involved in the reaction which donate or which gives energy to another molecule, those molecules which cannot undergo direct excitation though they are irradiated. So this is the photosensitization point.